Okay, the next one we are going to talk about is Fragile X syndrome. Fragile X syndrome, it is caused by abnormal number of repeat sequences in the genome, especially in the X chromosome, and then it causes mental impairment, from learning disability to from a severe intellectual disability. Is a mental retardation, and it affects the cerebellum a lot. It is a known cause of autism. Usually affects male more than female, again because male we don't have the Y chromosome, we don't have the second X chromosome to suppress the disorder, to suppress the recessive allele. Hemophilia. Hemo means blood. Philia means like friend or like. So it means that the patient, they like blood. That means they are friends of the blood. They're making friends with the blood. In this case, meaning that when they start to bleed, they cannot stop because the blood, they like to see their friend. It is caused by the absence or minimal of the clotting factor. So hemophilia is an X-linked recessive disorder that affects the clotting factor. There are two types. Type A does not have the clotting factor 8, and type B, you know, clotting factor number 9, 8 and 9. And then either does not clot. When they have hemophilia, either the patient cannot stop the bleeding, or it takes a long time for them to clot the blood. They can, it is easy for them to bleed externally, but they can also bleed internally, especially in the joints. That means when they have a bruise is basically an internal bleeding. If they have bruise, the bruise can get actually bigger and bigger and bigger. One famous case of hemophilia is in the Russian royal family. The reason is that Alexei is the famous royal family member that has this kind of hemophilia. One story is that the royal family go to the boat trip. Alexei he jumped to the boat, and then he get a bruise on his knees, and then the bruise is actually getting bigger and bigger because he has the internal bleeding. And then he actually fainted because he lost so much blood inside his body. And then the famous mad monk, Rasputin, he has to come and help to stop bleeding from that injury. Then it happened. This kind of genetic disorder happen a lot in the royal family because the royal family, as you know, that they like to have marriage among the royal family, so that they many of the recessive disorder cannot be covered up by the dominant gene, because all the royal family they may share the same recessive allele, and the occurrence of the genetic disorder will become very high. It says that except from a red blood cell, any cell can be a source of chromosome for examination. The reason is that red blood cells, they do not have nucleus. Red blood cells do not have nucleus, that means they do not have a chromosome or chromatin. In this case, that's why red blood cell has a very short lifespan, approximately 120 days. Karyotype meaning that we arrange and sort out the chromosome according to the size and the general appearance. we do karyotype so that we can classify the chromosome into 23 pair. So you can see that chromosome number 1 to chromosome number 22, we call them autosome. And the 23rd pair, X and Y, they're the sex-determining chromosome. And then each pair of the chromosome, one is from father, one is from mother. We call this homologous pair of the chromosome. So again, humans have 22 autosomes and 22 pair of the autosome and then 1 pair of sex chromosome. So instead of 2 sex chromosomes, that means it is 1 pair, and then this is called 22 autosome pairs. Okay, so the autosome they use pair, then sex chromosome they use the number. However, it's not a fixed case. Some people they may get more than two chromosomes for each pair, and it can be either in the autosome or sex chromosome. They can get too many or too few autosomes or sex chromosomes for each pair. Non-disjunction, it is still non-disjunction, meaning that when during meiosis they split in a wrong way. It can occur in meiosis 1, non-disjunction can occur in meiosis 1, or it can occur in meiosis 2. When non-disjunction occurs in meiosis 1, the homologous pair, instead of splitting a homologous pair into 2 daughter cells, both pairs will go to the same daughter cell. Or when non-disjunction occurs in the meiosis 2, what happens is that the sister chromatid fail to split and into each daughter cell. So the sister chromatid, they will go into the same daughter cell. In this case, you can cause trisomy or monosomy. Trisomy meaning that you have too many chromosomes. Monosomy, you have too little chromosome. So in trisomy, tri meaning 3, you have 3 copies of a chromosome. Monosomy meaning mono means 1, that means you only have 1 copy of the chromosome. So here, if you have non-disjunction occur in meiosis 1, that means the homologous pair of the chromosome go into 1 cell instead of 1 chromosome on each cell. Then in this case, when you finish meiosis 2, some gamete will have the 2 chromosomes in 1 cell, and some gamete you don't have any chromosome. After fertilization occurs, you have trisomy for this zygote, but you have monosomy in the other zygote. On the other hand, if you have non-disjunction occur at meiosis 2, meaning that in meiosis 1 you have successful splitting a homologous chromosome. And when non-disjunction occurs in meiosis 2, what happens is that the sister chromatid fail to split into each cell, just like this part. This part is a normal meiosis 2. Then you have the sister chromatid split into each cell. You have sister chromatid concentrate into 1 cell. And what will happen is that you have normal fertilization forming a zygote. Each cell will have 2 ends. In here, 1 cell will be trisomy, 1 cell will be monosomy. So if non-disjunction occurs in meiosis 2, you will also have trisomy or monosomy.